The first problem that I want to work involves the average rate of change of a polar graph. So here is the problem. It says in the polar coordinate system, the graph of the polar function r equals f of theta is shown with a domain of all real values from 0 to 2 pi. On the interval, the graph has no holes, passes through each point exactly one time, and as theta increases, the graph passes through the labeled points A, B, C, and D in that order. On which of the following intervals is the average rate of change of r with respect to theta the greatest? Well, let's go through the answer choices here, and let's try to make sense of what they're asking us. As theta is increasing, what they're saying is that we are traveling along the path of this function in the order from A to B. So as we travel from A to B, it is clear to see that the distance, which is r, is increasing. You can see it growing as you are moving from A to B. So one thing that I know is the average rate of change then from A to B, it has to be a positive number, because what I would be doing is I would be taking to find the average rate of change, I would take this r, which is 6, minus this r, which is 4. So the average rate of change, if I were to actually do the calculation, would be 6 minus 4, and that would be pi over 2 minus 0, because the theta right here would be pi over 2. The theta over here would be 0. And so that would obviously be a positive average rate of change, but I'm not going to really bother calculating it, and here's why. Because all I have concluded right there is that the average rate of change is going to be a positive value. If you take a look at from A to C, that is going to be an average rate of change of 0, because here the r is 4, but over here when you get over 2 pi, after you've rotated from 0 to pi, also the r is going to be 4. So that's going to have a 0 average rate of change. Then if you travel from B to C, the average rate of change is going to have to be negative, because again, you're traveling along this path and the r over here is lower than it was where you started. So that means the average rate of change from B to C would have to be a negative value. So that one's going to be negative. And then therefore from B to D, that's also going to be a negative value, right? Because you are starting with an R of 6 and the R is continually decreasing until it gets down here to a value of 2. So it's also going to have a negative average rate of change. So therefore we are going to go right here. Not that one, B. We're going to go with A, because that's the only one that's going to have a positive average rate of change. All right, I wanted to do one other problem here. And let's see if I can find it. Yeah, it was number 156, the one right after it. And we want to talk a little bit about this and try to see several different approaches you could take. So here they give you a function f of theta is 4 cosine 2 theta, graphed in the polar coordinate system. As theta varies from pi over 4 to 3 pi over 4, how is the distance between the origin and the point with polar coordinates, f of theta, comma theta, how is it changing, the distance changing? So what I'm going to do, first thing I'm going to do is I'm actually going to graph this function by actually graphing y equals 4 cosine 2x and see what that function looks like. Now, one thing I know is it is going to be a cosine that is going to start at its maximum because it is a positive cosine function. There is no horizontal shift to it, so it's going to follow through one period that typical cosine. Now, it is going to be up here at 4, coming down here at -4 because it does have an amplitude of 4. And in the period, though, let's see what the period is. So b is 2. The coefficient in front of my x is 2. So one thing that I know is period is going to be 2 pi over 2. It's going to be pi. So this is going to be pi radians, Halfway is going to be at pi over 2. This will be pi over 4, 1/4 of a period. And then over here is going to be 3 pi over 4. And so we're talking about this section of the function right there. Now, what is happening here? Well, if we're talking about the distance increasing or decreasing, if you're moving further away from the x-axis, then that means the distance has to be increasing. So let's just take a look at what's going on. Over this interval from pi over 4 to pi over 2, r is increasing. Because what's the function doing? The function's decreasing, but it's also negative. So if the function is decreasing and negative, then we know that that r has to be increasing. But as soon as it gets past pi over 2 and starts heading back towards the x-axis, r is going to be decreasing. So I need to choose an answer that says that r increases and then it decreases. So when you take a look at our answer choices, it's going to be C. The distance increases, but then the distance will be decreasing. Now, the other thing that I wanted to show you, I want to show you what this looks like on a polar graph. Now, this really isn't something that would be too easy to do by hand as you're answering that multiple choice question without a calculator. But I did want to show you that if I graph this function, and I've got this Desmos equation set up to graph right here, this function r equals, my a is set at 4 and my n is set at 2. And also I took my slider that is actually increasing the angle. I'm starting it at an angle of pi over 4 and then going to 3 pi over 4. So this is really where we're starting right here. This is where the function starts when theta is 0 at 4, which again is going to correspond to being right here. Okay. So, but when we get over to pi over 4, that's when we have returned in the graph, we have returned all the way here to the pole. So as we increase from that, let's see what happens. As we go from pi over 4, you can see that as we keep going, you can see that the r is getting further and further away from the pole. And then it reaches its maximum distance of 4. But then as I keep, and look where I'm at. Right here, I am at halfway between pi over 4 and 3 pi over 4, which would be pi over 2. So I am at this location right here. On this graph, I am at a -4. And here, that's where I'm at. I am at pi over 2 with an r of -4. That's why this thing's graphing down here, right? Because I've rotated to pi over 2, but that gives me an r of -4. So we go out 4 units on the back end of that pi over 2 rotation. But what happens is, as the slider now moves towards 3 pi over 4, you can see that the distances to the pole are getting smaller and smaller. So r was increasing and now it is decreasing, and it will return at 3 pi over 4, it'll return back to the pole. So this whole loop right here is being created over that interval pi over 4 to 3 pi over 4. And again, that corresponds with this function going from pi over 4 to 3 pi over 4. It was the r values were increasing and then they were decreasing as we returned back to the x-axis. All right, students, I hope that helps. That's 2 problems, multiple choice problems. And this coming Sunday, which is May 11th, which will be 2 days before the AP exam on the 13th, I'm going to do another live stream. I've done 2 so far for AP Precalc. I think 2, maybe 3, but I'm going to do another one this coming Sunday at 7 p.m. on my YouTube channel. And what we're going to focus on are multiple choice questions, Unit 3 and Unit 2. All right. I did a lot of multiple choice last night in my live stream at 7 o'clock. I did mostly Unit 1 and did a little bit of Unit 3. So we will focus on Units 2 and 3 this coming Sunday. All right, everybody, have a great week and see you soon.